All right, so it says, if possible, rewrite each of the following expressions using the properties of exponents. And I'm going to go ahead and say it's possible because they all have the same base number. They all have base numbers of 3, so we can use our properties of exponents. When we need to make a poster of this. When we're multiplying, we just add the exponent. So this is really 3 to the b plus c. This is in the exponent. Same thing here. This is going to be 3 to the, I'm just going to say c minus b. You could say negative b plus c, but either way works. This is going to be 3 to the, oops, I might have spoken too soon. We won't be able to do it because when we're adding the same base number with the exponents, we can't combine the exponents. So this one, we're not going to be able to change. But here we're multiplying again, so this is going to be 3 to the b plus 1. 3 to the 0 is just 1. 1 times anything, this is just going to be 3 to the b. This is going to be 3 to the 2c plus b plus c, which is equal to 3 to the 3c, because there's actually 3 c's, plus b. Cool. All right. Let's see what's next. Use the idea of an inverse to calculate the measure of the indicated angle in each triangle. So what are we talking about? We're talking about sine. So the sine of x is equal to 7 over 12. Okay, so in your calculator, if you put the inverse, remember if we take the inverse sine of both sides, then we just have x is equal to the inverse 7 over 12. And if you put that into the old calculadora, let's see what we come up with. This slow. Here we go. Hide. Okay. So what does that look like? It looks like the second sine, parenthesis, what was it? 7 over 12. And we get, let me just make sure I'm in radian mode, so I want degree mode. It might make a little bit more sense. And second, enter. 35.68, was it 7 over 12? Yep. So x is approximately 35.7. And on this side, it's going to be the same, but it's going to be, I know the cosine of y, because y is right next to this side, is equal to 5 over 15. So I take the inverse cosine of both sides. And I get y is probably approximately second, then you do second cosine, and that brings up the inverse, and then I'm just going to do 1 divided by 3 because that's the same as 5 over 15. And approximately 70.5 degrees. These are both degrees. Cool, so we are going to be starting trig in the coming up, if you can't tell with all of these practice problems we're doing. Factor the following expression. So 4x squared is 4 times x minus y squared is y times y. So I can't factor it like that, but they are each, it's the difference of squares. That's what it wants us to do, the difference of squares. So it is the square root of 4x squared is 2x, and the square root of y squared is y, and 1's plus and 1 is minus. There we go. And this one, oh, this one's also the difference of squares. The difference, of course, means, that's the name of the rule, the difference means subtraction. That's why we call it the difference of squares. You might want to take a little bit of notes on that really quickly, if you haven't already, because it keeps coming up. So I imagine it's going to be a big thing here. My alarm's going off for some reason. Hold on. That was my alarm to remind me to do homework. I don't know if you guys do that. Okay, so the square root of 9z to the fourth is 3z squared. 3z squared minus y plus y. Cool. One more question. Solve each of the following quadratics. Okay, so did they give us like nasty ones? That's okay. Let's start over here. Can we factor this? Are there two? Oh, nope, because this is not, we can factor it, but since that is not a 1, it makes it a little bit more complicated. But that's okay. Let's see if we can factor it. We're going to take 2 times negative 3, and that's going to be negative 6. So we're looking for two numbers that multiply together, give me negative 6, and add up to give me negative 1. Can that be done? Let's see. How about negative 3 and positive 2? I think that works, you guys. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. Okay, so what does that mean? That means in my square, in my area model, I'm going to fill this out. I'm going to put the 2x squared, my first term, here. I'm going to put negative 3, my last term, here. But there's 4 boxes and only 3 terms, right? 1, 2, 3, but there's 4 boxes. So the reason I found 2 other numbers instead of just one number, instead of negative 6, I'm going to use negative 3 and positive 2. I'm going to make that positive 2x and this negative 3x so I can fill in my area model. Then we're just going to factor the sides. So let's start here. 2x squared and 2x, I can take a 2x out of there. Then it's kind of like a puzzle. 2x times what gives me 2x? That's just 1. 1 times what gives me negative 3? That's just negative 3. Negative 3 times what gives me negative 3x? That's just x. So I have factored this. I know that 2x squared minus x minus 3 is the same as 2x minus 3 times x plus 1. But I haven't solved it. I've only factored it. And to solve it, it's equal to 0. If I make either, it's the property of 0. If I make either of these binomials 0, it makes the other one 0 because anything times 0 is 0. So this first one's easy. X plus 1 equals 0. Let's go back just a little bit. Let's split it up. Okay, there's the factored form. So what we're looking to do is like x plus what makes x plus 1 0, and also what makes 2x minus 3 0. This first one's easy. I just subtract 1 from each side, right? So x equals negative 1. That's one answer. That gives me 0. Negative 1 plus 1 is 0. Here's just a couple more steps, though. I'm going to add 3 to both sides. And then I'm going to divide by 2. So x equals 3 over 2, or what is that? It's the same as 1.5, right? So those are my two answers by factoring, vis-a-vis factoring. X equals negative 1 and x equals 1.5. Okay, just the factoring part, although it was the hardest part, don't give up after that because that wasn't actually solving it. That was just helping us solve it. So this one here, let's see. What's going to be the easiest thing to do? Let's go ahead and just distribute that 2. So 2 times 1 is 2 minus 2y squared plus y plus 1. Combine like terms. We have negative 2y squared plus y plus 3. Should we try factoring again? Let's try it. It's just always the easiest if it works out, in my humble opinion. So here we have negative 2 times positive 3. Oh, that's negative 6 again. And I have a positive 1 down here. So you guys, I think what's going to happen is we can still use 3 and 2, but this time my 2 is going to be negative and my 3 is going to be positive, right? Because this number has to be bigger. The positive number has to be bigger if my answer is bigger when I add them. So then I make my square, my area model, and I put in my trinomial, which is now 4 terms instead of 3, instead of the actual trinomial. So this first part is negative 2y squared This is plus 3. Then I'm going to make this negative 2y, and I'm going to make this positive 3y. Now I'm putting the y. I found these numbers, but when I actually put them into the area model, they have to have a y there. So I can do it on either side, so I can keep doing it on the right side, but I can just change it up since I have more room over here. Negative 2y squared and negative 2y, I can take out an entire negative 2y. Okay, negative 2y times what is negative 2y? Well, that's just going to be 1. 1 times what is 3? That's just going to be 3. 3 times what is 3y? That's just going to be y, and we can check y times negative 2y is negative 2y squared. So I have factored it. It was factorable. And it becomes negative 2y plus 3 times y plus 1. But I haven't solved it. I still need to solve each of these for 0. So I already know one of my answers is y is going to be negative 1, right? So I'll just put that there. Y is equal to negative 1. That's what makes this 0 here. But to make this one 0, I'm going to negative 2y plus 3 equals 0. Add 3 to both sides. Negative 2y equals, oops, I'm subtracting 3. Negative 3, right? That's the opposite, is minus 3. And then divide. You guys, look how cool this is. Then you divide both sides by negative 2. So what I do is I still get positive 1.5. So my answers are still positive 1.5 and negative 1. It's the same answers I got from the other one. So what do you think is going to be the difference? Let's check out a graph. 2x squared, let's see. 2x minus 3 times x plus 1. Let's do this. Where's my Desmos? This is going to be cool, you guys. Close out of here. Whoops. Whoops. All right, so I graphed these. The first one, whoops. The first one here is the red one, right? And it's a positive. And then the second one we solved for was the blue one. It's a negative. But why did we get the same answers? Because the solutions of a quadratic, if you guys remember, the solutions of a quadratic are actually, I wonder why my old stuff keeps coming up right there. The solution to a quadratic, another word for them is zeros, right? And if we look at the zeros, or we look at where it crosses the x-axis, they cross at exactly the same point. So even these are completely different. Even these are completely different functions, and they even look different. They still have the same solution because they still cross the x-axis at the same place. And I think that was the last one. So I hope you're having fun going over these, and I will check them off the next time I see you. Go Broncos!